All right. So, welcome to the third module of this course, Engineering Data Analysis. And in this time, we are going to talk about correlation and linear regression. Right? We're going to introduce the terms only. We're not going to deal with much computations. Especially in this part, the computations are now starting to become more and more not really complicated, but uh, very tedious, okay, and time consuming, right? Anyway, so here we're going to explore the relationships of variables, especially the independent and dependent, and more often than not, we are focusing on the what we call numerical variables, right? So without further ado, let's proceed. Right. Sorry. So correlation is basically the statistical technique used to evaluate how two variables are related. Two variables, more often the independent and then the dependent. And typically, we express it as a correlation coefficient R, which ranges from -1 to +1. Okay, so if you have seen, as you have noticed in the right side, we have this different types of correlation. So as you can see, we have the positive and the negative ones. Okay, positive here and then negative ones. So meaning if our correlation coefficient is negative, a negative number from -1 up to almost zero, um, they will belong here. Okay, and as you can see, it's just like the slope. So negative R means negative slope. So downward trend. There's a downward relationship, right? While if our R is positive, then we'll notice an upward trend. Okay, and another thing, you can see that there is a positive, a strong, and a weak correlation, or I mean a perfect, a strong, and a weak correlation. So that happens in both our negative and positive correlation, right? And that is basically determined by um, what we call the correlation coefficient R, specifically the Pearson's correlation. Um, when we are talking about numerical types of data. Okay, so numerical, whether we have interval or ratio data. Um, we have the other type of correlation, the Spearman's rank correlation, and rank means it is something ordinal. So when we have things like Likert chart, or we have our data is in terms of ranking or some sort of order, then we can no longer use the Spearman's correlation. Instead, we use this. I mean, we can no longer use the Pearson's correlation. Instead, we use the Spearman's rank correlation or the Spearman row correlation. Okay. Correlation, by the way, enables researchers and engineers to uncover insights, identify patterns, and focus on key drivers of system behavior. And you're going to see later why. Okay. So just remember, for now, positive correlation, we can expect an upward trend because positive R means positive slope. While negative correlation is we can see a downward trend. Okay. And if we cannot identify whether that is an upward or a downward trend, somewhere in between, then that's the time we can say there's no correlation between the variables. And we'll explain later what do we mean by that, right? Um, when we compute for the Pearson's R correlation, actually we don't, it is no longer advisable to compute it manually. Although you can, but it is very time consuming. So many statisticians, engineers usually use spreadsheets or some statistical software to compute for the R. But if you would like To compute it on your own, then you basically need to list down first all your pairs of values. Okay, value from the independent variable, which is x, and its corresponding counterpart on the y. Right? So we list down all the x, y pairs, and then take the mean of all the x's, take the mean of all the y's, and then we create a table, starting with all the x's, and then all the y's. So after that, we have another column wherein we subtract the mean from each of the x's. Okay, until we complete the table. So we have the xi minus x bar, xi minus the sample mean. Okay, so once we complete that, we do also the same with our y. So we add another column on the y part. So we list down all the y's minus the sample mean. So um, you complete the table and then we proceed with the next one. The next one, we need the product of the two. Okay, product of the difference in the x's and the difference in the y's. And then after that, we take the square of the difference between the x's and the means and the mean, and we we square that, and same thing with y. Okay, so we take the sum of each, and then we basically just substitute once we have that. We take the sum of all the products of the x of this one and this one, and then we take the sum of all the squares of the x part and all the squares of the y part, and then multiply before you take the square root. Okay, so as you can see, it's quite complicated, and if we discuss it here, how to do it, it will take a long time, right? But the process is easy, actually. It's just time consuming. Um, Regarding the Spearman's correlation, we usually use the symbol rho, Greek letter rho, but in some textbooks they use the R sub S. Right? So just take note of this formula if you want to compute it manually. Right? Um, okay, so you can here okay, I think don't no need to read this. You can take a screenshot if you want, and you can read it on your own. We have more details about the comparison between the Pearson correlation and the Spearman correlation, right? And now, while correlation is a powerful tool, it must be interpreted carefully. Okay, we have these four things to bear in mind. Number one, correlation does not imply causation. So, for example, that means a strong correlation does not mean one variable or the independent variable causes changes in the other, which is our dependent variable. So, for example, ice cream sales and drowning incidents may correlate due to a confounding variable, and that is a hot weather. Okay, so that means, for example, there's a time that um, or there's a certain place where the maybe the mayor or whoever the maybe the assigned researcher has noticed that whenever there's a significant increase in the ice cream sales, there will always be a significant increase in the number of drowning incidents. So meaning the more ice cream sales there is, the more drowning incidents. So this is not a coincidence, but it doesn't also mean that the ice cream is the reason why those people are drowning, right? It is simply because during hot weather, many people would likely eat ice cream. And at the same time, many people will also would like to go swimming, right? So meaning more people swim, more chances that there will be drowning incidents. right? So we have the term confounding variable. So it's something in common between the two. Okay. So now, number two, take note that in correlation, it is very important to determine the direction of the relationship. And that is determined by the sign of our coefficient. Okay, I already mentioned if we are R is positive, then we have an upward trend. And if the R is negative, we have a downward trend. But additional context is often needed to explain the relationship, especially the magnitude of R. So once we should know how far it deviates from zero, or how far it approaches, or how close it approaches one, okay, or negative one. Right. And there are many other things that we have to consider also when we are stating the relationship of two variables. And as mentioned earlier, it basically depends on the magnitude of the R, or the value of the R, which determines the strength of the relationship. Okay, if the sign determines the direction, the magnitude of the R determines the strength of the relationship. So let me zoom in this one. Okay, so when we say strength of relationship, we basically have this range from the negative perfect up to the positive perfect correlation. So negative perfect, we can expect a straight line going downward. Okay, same in the same way, when we say positive perfect, we have a straight line going upward. Okay, and in between them, the most middle in between is the zero, or the no relationship, wherein we cannot create either uh, uh, downward line or an upward line. So neither. We cannot create a pattern at all, or we cannot see a pattern at all. Right? And in between the no relationship and the perfect relationship, we have the strong and the weak. Okay, so strong, very large. Okay, either negative or very large positive. We consider that as strong. Large, we consider that as moderate. Okay, while medium and small, we consider that as them as weak. And of course, when it is very close to zero, we consider that as no relationship. And you'll see later what's with this relationship. Why do we talk about this? Right? Number four, take note that non-linear relationships also are they also exist, right? Correlation measures linear relationships, and two variables may have a strong nonlinear association that R fails to capture. Sometimes when our pattern does not seem to or does not appear to be a straight line, then there's still a chance that there is a relationship between the variables, but that relationship may not be linear anymore. Okay, so that's a special case and a more complex type of correlation. All right, so I hope right. I have explained enough about the strength and direction of relationships. Right, and that's all for now, and we'll continue in the next part.